Hi, this is Ramya. This project is about sorting techniques, the various sorting techniques, and the visualization of it. So, we have to implement the different sorting techniques such as bubble, insertion, selection, quick, and merge sorts. And then we have to show visually how they perform on sample data sets. And then with the experiment, we have to analyze the inferences from the experiment. So, the first sort is insertion sort. So it can be called as an in-place sorting as well. So each value is compared with the largest value in the array, and if the compared value is larger than the selected value, then the largest value is sent on top. So that and it is exchanged and it's moved. So the next one is the selection sort. So in selections are actually from the array of elements, the smallest unsorted element is moved to its place where it has to be in the array, and it has n minus 1 moments, so that is the mathematical process. So the next sort is the bubble sort. So bubble sort is two elements are taken and the first element is compared with the second and swapped if the neighbor is less than that element. So till the last element goes off. So the largest element is on top in the bubble sort. The quick sort is the most efficient sort for all the data sets. So you take any random element as a pivot and then compare all other elements of the array with the pivot and move accordingly. So next sort is the merge sort, where you have to partition the unsorted array into two and then sort each partition and finally merge the partitions. This time each partition here comprises a memory in the merge sort. So these are the types of data set that we are using. So I have used 4 sets of data for the actual experiment. For the recording purpose, I have just randomly selected 10 to 30 elements of the data set. So as far as the inferences are concerned, so usually quicksort works more better on all types. So this is a visual way of showing you how it is done. So I just have a G panel that is going to take the sorting technique into consideration, and in the array size that is going to be 30 and 10. So that is going to pick randomly from the sample data set, and then the scale is the size of the pop-up window, and the speed is the speed of the movement in the histogram. So the sorted elements are going to be shown in green and the unsorted elements are going to be shown in purple. The two elements which are sorted are highlighted in yellow. There's also a gray color which shows temporarily sorted or unsorted elements. So as you could clearly see, bubble sort takes a lot of time for larger data sets. Usually bubble sort is quicker on very small data set. Also bubble sort is quicker on sorted data sets as well. So now I'm going to take 10 as my array size and just keeping the speed and the scale same so that it is the same for all the so as you could clearly see, for 10 it is very fast when compared to 30. So next is going to be insertion sort. I don't find much of a difference between bubble sort and insertion sort. The timing, it usually takes the same mostly. So for 10 elements it's sorted quickly. Kindly excuse for the noise of the image that has been recorded. So similar to bubble sort, even insertion sort takes a lot of time. array size varying from a dataset which is around 50,000 or something. So it randomly picks numbers from the array. I don't have a fixed number of elements in the array. So insertion sort has completed its sorting for 30 elements. So now let's do a selection sort for 30 elements. It's done. So now we're going to do a selection sort for 10 elements. So as far as 10 elements is concerned, I think almost all the algorithms perform fairly consistent for a very small data set. So it doesn't make a difference if we're going to do a sort on a limited number of data. So next is going to be quick sort. So as far as the experiment is concerned, both for 10 elements as well as 30 elements, quick sort performed better. For 10 elements, there was not significant difference between the other sorts. For 30, I think you could visually see how fast it is and how efficient the quick sort is. With the pivot, just partitions the elements into two and then just sort the subpartitions. It just takes half the time of bubble. So that's 30 elements. That's quick sorting. Last one is the merge sort. I'm going to do it for 30. So merge sort, though it's similar to quick sort, its way of sorting and also the performance, I think merge sort and quick sort fairly did well with larger data sets. The only negative thing for merge sort is that it uses up some memory for its partitions. So for its memory imprint, I think merge sort is not considered for larger data sets. Quick sort is more efficient. So for 10 data, it is fairly consistent. So that's the visualization part of it. So those are the inferences that I had discussed above. So I think for all type of data sets, I prefer quick sort. Thank you for hearing.